Okay, so we've done the sort of look through vaccine types, a little review there, and we've done the look at what happens actually following immunization with a vaccine or with an actual virus. Now we're going to go on to the actual process of making vaccines, and we're just going to touch on this with a couple of fun examples. And then, if you want to know more about this stuff, there is a summer vaccine course that you'd be able to take that would go into this in much more detail, if this is your kind of thing. So yeah, we're going to look at the rotavirus, the dengue virus, and a little bit of human papillomavirus. So rotavirus is going to be a virus that causes a lot of diarrhea, and this is actually a killer. Kills a lot of children every year, lots in Africa, some in southern Asia. Dengue virus is going to cause a hemorrhagic fever, not completely unlike Ebola, but it's going to be interesting in that this is one that the first time you catch it is probably going to be mild, and the second time you catch it is going to be very severe and could become life threatening. So, yeah, it's a virus that has to hit you twice to get you. And then human papillomavirus is going to cause cervical cancer, among other kinds of cancer. So let's start with rotavirus. So here are some little rotavirus particles. Look at them. Aren't they beautiful? So it's in the family called the Reoviridae. It's going to have double-stranded RNA as its genome. And it's going to be fairly small, about 85 nanometers in diameter. Would be around the same size as a coronavirus particle, similar to that. A little bigger than a poliovirus particle. Nearly spherical, icosahedral symmetry, not enveloped, but does have two shells around the outside. So there we go. And you can tell them pretty easily under an electron microscope, because they're the only thing that really looks like that particular appearance. Okay, the genome of a rotavirus is 11 segments of double-stranded RNA, and so it takes that segmenting idea that influenza viruses use and just takes that to the extreme. So on the outside, you've got a thing called VP4, and VP4 is going to stick out. It's going to serve the role of the spike protein. On the inside, you're going to have VP6. This is going to form the core that's underneath that particular one. And then you're going to have, let's see, VP7 is going to be a little tiny piece that's on the outside, and VP2 is going to form the central core down in here. So we classify rotaviruses based on antibody neutralization, because this is kind of how your immune system would see them. If antibodies recognize these viruses as different, then probably somebody's immune system will. And so they can cause potentially different kinds of disease, or protection against one might not be protection against another one. Yeah, they're defined by neutralization with antibodies of different specificities, so different kinds of antibodies. And so these are going to be looking for the VP4 and the VP7 antigens. Let's just go back here. And so the VP4 is the bit that sticks out on the top, and the VP7 is the little bit that's underneath that, and they're going to act together, 4 and 7. And that's what your immune system is going to see for the most part. So in most of the world, most of these cases of rotavirus are going to be type 1 strain, so the G1 strain, genotype 1. And there'll be smaller amounts of some of the others. G2 and G4 are fairly big. A few people have a mix between more than one of these. And there are a bunch of other strains, but they're each very minor. And so if you could knock out the G1, or maybe the G1 and the G2 and the G4, you could have yourself, a very, very good vaccine, and it would help a lot of people, because this is a very bad disease. And the problem with this disease is that it hits parts of the world where there's not a lot of money for purchasing vaccines, for example, where there are other bigger problems in life. And so this just sort of contributes to the general difficulty of life in some of those places. Okay. Now, rotaviruses cause the highest level of diarrhea in both developed and developing countries. So rotaviruses are the biggest source of things that'll give you diarrhea. The difference is that in somewhere like America, for example, you will have nearly half of the cases of diarrhea are going to be from rotavirus, but there'll be a lot of other causes over here that we don't fully understand, and then you'll have little bits of things like bacteria. If you were to go to a developing country, it'll have about the same amount of rotavirus, but it will also have large amounts of like E. coli sort of poisoning, different parasites in there that would be uncommon in the developed world. So each dot is 500 deaths in a year, and so this is showing where the 800,000 deaths per year from rotavirus tend to be. That's a pretty big number, right? Yeah, compare that to the number of people that died from Ebola and the coronavirus and the flu over the last, I don't know, 3 years, 4 years. And yeah, rotavirus, I believe, is going to have killed more people every single year. Problem is, they're mostly going to be in places that don't often make the news, or don't often make the news outside of the region, let's say, or places where there are a lot of people, and yeah, there's just nobody. I don't know. There's like a political and social dimension to this thing that I'm struggling with, but that I think is very important. You can see that there are some countries in the world that have very little in terms of rotavirus cases, at least very few deaths. And the deaths can typically be prevented by other things like good infrastructure and good enough hospitals that you don't end up with multiple infections, access to medical care, stuff like this. But yeah, rotavirus is a big problem, a real big problem. Okay. So how does the rotavirus work? Well, it's going to attach to the cell. It's going to go through an endosome where it gets acidified. Once it's in there, it's probably going to protonate a histidine for sure. And it's going to release the core particle. It's going to get rid of that outermost shell. And then from there, it's going to go off and make its RNA copies and make its new capsids and assemble and then leave, something like that. So a fairly typical virus replication cycle. They're going to infect the upper 2/3 of the duodenum's epithelial cells. So the duodenum is the little part right by where the stomach and the intestine meet. And the infectious particles are going to be released into the intestinal lumen, which read into the poo, and undergo further replication in further down the enteric tract. They can cause very severe diarrhea, vomiting, and abdominal pain. Diarrhea is so severe it results in complete dehydration. And yeah, it's got about a 2-day incubation where you don't know you have it, and then 3 to 8 days of extreme watery diarrhea. During which point, unless you are on a intravenous drip or something like that, it is possible to die. And so they do kill over 600,000 out of those 800,000 that die every year are children that die of rotavirus. So this is a thing that's very much worth vaccinating against, but it's a thing that doesn't hit most of the countries where vaccines are developed very hard. So this is the sort of vaccine that would have to be made almost charitably. You're not going to make any money off of something like this, probably, but it would do a lot of good for a lot of parts of the world. And so here we go. Yeah, this is something that is being attempted with several medical charities helping out. So pathogenesis, what does rotavirus do to you? Well, shown here, this is the small intestine of a healthy individual. And these are the little cells that are going to be secreting the digestive juices. And then as you can see here, this is rotavirus infected small intestine. And you just got sort of disruption. You've got some of these cells that are just hollowed out and dying. They don't look good. They're not doing their job anymore. That's because of the infection. The infection is what's doing this to them. So people have tried to make various rotavirus vaccines. And one way to do that was to make VP7. So you remember VP7 was the shell on the inside, and VP4 kind of slots into that shell. And so they tried to make a tetravalent shell with VP7 and VP4, and with different versions. And then they, so with serotype 1, 2, 3, and 4, and this was found to be safe and immunogenic, and so it went into human trials. And the first that was released was called Rotashield, and it was withdrawn after about 6 months. And here's one of the original packets, and let's go look at why. So here's our timeline. FDA approves it. They've done their tests. Everything seems all right. It gets recommended for universally recommended for use. So that's great. Yeah, we're going to get this out to people. And then over the first few months of use, from September 98 to July 99, there are millions of people treated, including a lot of infants. But 15 of those infants develop a condition called intussusception. Intussusception is when it's when the small intestine and the large intestine, the small intestine basically pushes into the large intestine. The large intestine is backed up around it. It causes a condition something like appendicitis, where you get a little pocket with bacteria in it that's kind of fermenting on its own, and it can sort of swell up and cause problems. It can be potentially life-threatening, and it can be corrected fairly easily with surgery if it is happening. But yeah, this very rare condition happened in 15 cases. And so the CDC reported that Rotashield was associated with intussusception and recommended postponing use. And so Wyeth, which was actually distributing the vaccine, suspended further distribution and didn't let anybody else have Rotashield until more data on the connection between the vaccine and intussusception became available. And so then they had to withdraw, there we go, by October 99, the Rotashield from the market. And yeah, then the ACIP, which voted to universally recommend it, voted to no longer use Rotashield for infants. It can still be used in adults, but it was withdrawn for infants, and it was withdrawn in general to try and reformulate. So what is this? Here's intussusception. So you get your small intestine, and it's going into the large intestine. What happens is that in some small babies, you don't have as much, the connective tissue isn't as developed, and you can get the small intestines kind of pushing in here and making these little pockets. You see how you get this little, you got the appendix down here? You're making a thing that's kind of like a giant appendix. And if this ends up joining onto that and sort of filling up with bloat and bacteria, then you can end up with a very painful condition for the baby that can be dangerous. Yeah. And so this is a rare complication. It's seen in premature infants in particular. And it was suspected that in this trial, there were a lot of premature infants who were given this Rotashield vaccine. They didn't know that it was going to be harmful, but it turned out to be harmful. And so they came up with a reformulation, Rotavirus, and here's different Merck Rotavirus vaccine. And these things have been developed, and they were going through trials, and now actually some of these things are through trials. And what you notice with a lot of these is that they're basically the same vaccine. They're going to have VP7 and they're going to have VP4 on the outside of VP7, just like before. They're going to be given in the same way. The only real difference is they will often give these with a vitamin supplement that actually helps protect babies against intussusception. And they've come up with a better checklist to make sure that the primary care doctors that are assigning the vaccine don't give it to babies who have been born premature because it could potentially cause, this complication, which would be pretty bad. And so you see a lot of the sort of big companies that are on this list. They're probably not going to make much money, maybe not really any money from this particular rotavirus vaccine, maybe a little bit over time. But each one wanted to develop this, and so that's actually kind of nice. And so there are different versions that'll work against one strain, the monovalent ones, 4 strains, quadrivalent ones, or 5 strains, the pentavalent one, which is pretty cool. Yeah. All right. So that's the end of rotavirus. Thank you.